Alright, so you're trying to understand neoplasms and cancer and pathomorphology, but you're just too dumb to do, and it's just way too much. So you're here, so I'm gonna show you how to do it in a few minutes. First of all, let's go to definitions. What is a neoplasm? A neoplasm is any abnormal mass of tissue with exceeding uncoordinated growth. That's its definition. So what is a cancer then? A cancer is a neoplasm, but a malignant one, right? That's its definition. Cancer is a malignant neoplasm. So neoplasms in general can be of two characteristics basically. They can either be benign or they can be malignant, right? Let's start with benign. Benign means harmless basically. If they're benign neoplasms, most of them actually end with the first, like the last three letters of it are OMA, so that's kind of a hack I keep in mind. And they can be either of epithelial origin or mesenchymal. Epithelial origin will include neoplasms like adenoma, cystadenoma, and mesenchymal ones, lipoma, angioma, and fibroma, right? So second one, malignant one, right? The bad ones, the ones that metastasize and have local invasion, as I've written here. Every malignant neoplasm has this thing of local invasion and usually also metastasis. But we see two exemptions here, which do have local invasions, but they do not metastasize, which are gliomas and basal cell carcinomas, right? So carcinomas, no, like first of all, as we already can see here, the malignant one can also be subcategorized into epithelial and mesenchymal origin, or vice versa into a carcinoma, which is usually in case of adults, and has the examples of adenocarcinoma and squamous cell carcinoma, which are very important to remember. And it can be a sarcoma, which is usually in kids, and on the opposite, it's also mesenchymal origin, and it's a liposarcoma and fibrosarcoma. So once again, you see that these abbreviations I wrote here of carcinoma and coma, you know, the abbreviations they end with. These are for the malignant ones, as we can see here, carcinoma, for example, and sarcoma, right? So for a quick table to recap, neoplasms, right? We have benign ones and malignant ones. Local invasion is always in malignant ones. They always metastasize, but remember I told you the two exceptions. But this is a general table, so yeah. We see malignant, we know, okay, they do have local invasion and they do have metastasis, right? They do not have a capsule. They do reoccur fast. They have a fast rate of growth. They have well to poor differentiation. Angiogenesis, here we can see 3 pluses, and heterogeneity, we can see also 3 pluses. So this is basically pretty easy to remember because you have to just think logically in a clinical sense. Of course, the malignant ones or the bad ones will always have local invasion. They will always have metastasis. They don't have a capsule, so they can easily distribute themselves among the tissue. They do have recurrences, of course. That what makes them so bad. You know, they recur every now and then. They have a very fast rate of growth, which is one of the main virulence factors, basically. And well to poor differentiation. And yeah, these are the key points. So on the other case, we can see benign one, right? Benign is the harmless one. And here we can see local invasion. No, they don't have local invasion. Metastasis? No. They do have a capsule, meaning you could kind of think that they have this capsule so they can't easily break out of that capsule and have a high rate of growth and metastasize. So capsule, yes. They do not have recurrences. They have a slow rate of growth, not like the malignant one, which is the bad one. And they have well differentiation. So you could well tell apart a benign tumor, a benign neoplasm from the surrounding tissue, right? And angiogenesis and heterogeneity in prospect to the malignant one is decreased, right? So look at that. All of that makes sense. You should be able to just see these kind of key factors and automatically, logically even, think what the answer for everyone is going to be, right? Because all of that is pretty self-explanatory. And so now let's move on to features of malignancy, right? So features of malignancy I included six features. First of all, pleomorphism, which, as we all know, is basically defined as a variation in size and shape of the cell. We have hyperchromasia of the nuclei. The nucleoli will be increased in size. We have irregular chromatin, and that is defined in its shape, size, color, and its distribution. We have an irregular cell nuclear membrane, and we have mitosis and architectural anarchy. All of these are pretty easy to see on the histological slides. So once again, 6 we can see here. These are the features of malignancy, all the features that will be on the cells that are talked about, or on the tumors that are talked about here. And yeah, so how about the spread? 3 kind of subclassifications. They can spread through lymph, so in the lymphatic systems, and reach the lymph node. They can spread hematogenously, which is mainly the liver, lungs, and the veins. And they can spread through body cavities and surfaces, mainly ovary, right? The growth fraction is very little here summarized, but there is a G0 phase with differentiation, which is basically defined as an extent to which neoplasms resemble a healthy cell. So G1 will be well differentiated, meaning it basically just pops out of the skin and you can see it with the naked eye easily. G2 is moderately differentiated, and G3 is poorly differentiated, right? And anaplasia is basically here a term you don't have to remember, but just keep it in mind that it's the lack of differentiation, right? Or in this case, proliferation without maturation. So these are kind of like the opposites. Anaplasia doesn't have differentiation, and differentiation obviously occurs here. So we also have necrosis and apoptosis, which are important here to remember, and important for diagnosis along with the staging and the TMN system. That's what basically this, as I told you, this growth fraction is for, right? So we have the staging, which we all know, the stages of cancer, and the TMN system, right? That includes the size of the neoplasm, lymph node involvement, and extranodal metastasis, right? Here is a quick table for tumor markers and clinical application cheat sheet, and you can look at it by yourself, and thank you.